In this video, we're going to talk about solving systems of two linear equations using the elimination method. Now, in the previous video, we solved these type of systems using the substitution method. And what we did was we solved one of the equations for one of the variables. But we found that it was easiest if at least one of the variables in one of the equations had a coefficient of 1. Okay, because that's the variable that we would solve for. You could use the substitution method even if none of your coefficients are 1, although it's a little trickier because there's a couple extra steps. You might have to deal with fractions, things like that. There's another method, though, called the elimination method that you can often use in situations like that. So we're going to do the elimination method in this video. And what we're going to do is we're going to take, for this particular problem, I'm going to take this first equation and multiply the whole equation by 3. Okay, now first of all, why am I doing that? And second of all, why is it okay to do that? Okay, well, let's talk about why it's okay to do that. Well, if the left-hand side of this equation is equal to the right-hand side, shouldn't 3 times the left-hand side also equal 3 times the right-hand side? Yeah, that's certainly true. If these two things are equal to each other, left and right side, 3 times the left side should equal 3 times the right side. Now 3 times the left side, multiply each of these terms by 3, we would get minus 6x plus 9y. Okay, and on the right side we would get negative 15. Okay, now why did I do that? Well, that's a whole nother story. But what do I mean when I say it's okay to do that? Well, any ordered pair, x comma y, that would make this first equation true would also make this equation true. Okay, and vice versa. Okay, now I'm going to keep the second equation the same. 6x minus 7y equals 17. So I still haven't answered that question, why did I do this? Well, the reason is because what we're going to do is add these two equations together, and the minus 6x and the plus 6x are going to go away. Now, first of all, why is it okay that I can add these two equations? Okay, I'm going to take the left side here and the left side here and add them up and put it here. And I'll take the right side here and the right side here and add them up and make it the right side down here. Now, why is that okay to do it? Well, think about it like this. If the left-hand side here, this is equal to the right-hand side, and this is equal to the right-hand side here, doesn't it make sense that this plus this, add the two left-hand sides, it should be equal to this plus this when you add the two right-hand sides. For example, in the first equation, think of it as you have some pile of sand on the left side and you have some pile of sand on the right side, and they're equal piles of sand. Okay, in the next equation, you have another pile of sand. Maybe it's a little bigger this time, but it's equal to another pile of sand on the right side. Okay, so you have a small pile up here and a small pile up here and a big one down here and a big one down here. Doesn't it make sense if you add these two piles of sand on the left side, it would be the same thing as if you add them on the right side? Yeah, of course that makes sense. Okay, so let's do that. Add these two equations together. Now on the right hand side we're going to get 2, negative 15 plus 17. On the left side we get negative 6x plus 6x. That's 0x. Okay, that's just 0. So we don't even have to write it. And what we also have is 9y plus minus 7y, that's 2y. And so notice we have 2y equals 2, or y is equal to 1. Okay, now why did I multiply the original equation by 3? Well, I wanted the x's to go away. So I said, oh, if I multiply this by 3, I'd have a negative 6x. Add that to a plus 6x, and it would go away. Okay, now the last thing, we're still not done. We still have to find what x would be. So let's take one of these equations. Maybe we'll take the second equation down there. 6x minus 7y is equal to 17. But we're going to plug in 1 for y to find out what x is. So what we have is 6x minus 7 is equal to 17. Add 7 to both sides. We get 6x is equal to 24. And divide both sides by 6, we get x is equal to 4. Okay, so the solution is 4 comma 1. And again, you can check that if you plug in 4 for x and 1 for y, both of these equations will be true. Okay, so this was using the elimination method. It's called elimination because we eliminated the x's. Okay, now let's do another problem where we solve using the elimination method. Now notice I'd like to multiply one of these equations by a number so that when I add it to the other one we get 0. But let's see, what would I multiply 3 by? Maybe 7/3? I mean, that would be kind of tricky to multiply by a fraction. And same thing with the y up here. What can I multiply this by? 5 halves? I mean, that would be tricky. I'd like to multiply by whole numbers. So instead of just multiplying one equation by a number, we will multiply both equations by numbers. So let's multiply the first equation by, say, let's do 5. Okay, so that in that case, our top equation will be 15x plus 10y is equal to 45. And let's multiply the bottom equation by negative 2. Now, why negative 2? Because I want to have a negative 10y. So I wanted a 10y and a negative 10y, so that my y's will go away. So if I multiply this by negative 2, I get negative 14x minus 10y is equal to negative 44. Okay, now if we add these two equations up, 45 plus minus 44 would be 1. The y's go away. We've eliminated the y's. And now 15x plus a minus 14x would just be x. Okay, so we have x is equal to 1. That's the x value of the solution. To find the y value, we could just go back to one of those original equations. Let's do 3x plus 2y equals 9 and plug in 1 for x. Okay, so we have 3 times 1 plus 2y equals 9, or 3 plus 2y equals 9. Subtract 3 from both sides, you get 2y is equal to 6, and so y is equal to 3. So 1 comma 3 would be the solution. Okay, now you might wonder, why did I choose the 5 and the minus 2? Well, it was just kind of arbitrary. I could have chosen multiply the top equation by 7, let's say, and the bottom equation by negative 3, and that way we'd have a 21x and a minus 21x. It would turn out that your final solution would be the same. In fact, you should try that. Try multiplying the top one by 7, the minus one by 3, or the bottom one by minus 3, and you'll see that your solution still ends up being the same thing here. Okay, so that's the elimination method.